Hello, my name is Nicholas. My partner is Tristan, and today we're going to be working on our ANSYS Fluid Project 1. My first step is going to go to my geometry, right click, go to properties, and then we're going to be changing this to 2D. Exit out of there. And then I'll right click again and go to design and model. Third. Whenever that opens, I'll start back the recording. All right, perfect. It's opened up. So first things first, I'm going to click to my Z axis right there and start my sketch. I'm going to make a rectangular shape. That big is fine. Then we're gonna, oh, I know I can't see. Hmm. We're gonna go to dimensions, get our horizontal length right there. Horizontal. Go and made my dimensions right there, and I'll be able to edit them right here. For the case of this project, throughout all three cases, I kept my dimensions the same, just edited other variables to make my Raymond's number correct. So we chose 1500 and 10 as our height, 10 meter, 1500 meters. Well, first things first, I have to change my meters to millimeters. I'm gonna go up to here to units to millimeter. Yes, so this is gonna be 1500 millimeters. And we have 10 to comply with our constraint of our length being 150 L. Right, so here if we zoom in, you can see our thing. So we're gonna go the concept, surface from sketches. Oh, we're gonna go to box select, which I can't see. We select our surface, apply, enter, generate right there. Now we have a surface. Now we can go to our workbench and we have a green check mark. Meshing, double click our mesh. This might take a while to open, so I'll get back to you when it's opened. Here, now we see our beautiful thing. So first things first is going to be we're going to create names for all of our um sides so we don't get anything mixed up in the future. If I can zoom in. I'm gonna go here to edge, I believe. Edge, right click, click, create name section. I believe I clicked the lower one first, so lower wall. If I click up here, right click up here, we're gonna name this upper wall. Click here, inlet. This is going to be our output. If I can, no, not that one. Not that. Here. Maybe we have all our name. You can right click mesh, insert, and then sizing. Sizing. We're going to select the upper and the lower wall with the control click. Yeah. Click apply. We're going to do it based off number of divisions. I'm going to choose 2500 divisions. Change this to no, to no, and then change your behavior to hard. And we generate that mesh. This might take a while, so I'll get back to you when it's done. It's just done. If we zoom in, we should be able to see something. Oh, it hasn't loaded. Well, either way, we're gonna do our edges for the sides now. We're gonna mesh the sides. Yeah, there you can see our mesh. So sizing a new one. So if I can click that side right there and that side right there. Yep. Apply to edges. Same conditions as before. But this time I only choose a number, 50 number of divisions, since it's going to be a smaller area. And here we'll be generating. This should take a while, so I'll get back when it's done. Now that our thing finished meshing, now it looks like this. Now I want to do a face mesh. So go to here, right click insert. Where's face mesh? Mm-mm. Oh, right here, face mesh. Select our thing, press apply. Now we generate. This shall take a second and I'll get back. Oh, it finished. Perfect. So it should look like this. Very nice meshing. Here we can go back to our workbench. Update here. And as soon as it's a check mark, now I can go into our setup. Change this to stubble position. But it should just give us the same option if we double click that right there. There you go. Double position 2D. Here it's opening. Second. Oh, come on. Every time I do it. The Well, first things first, I'm gonna go to my results, change my residuals. 0.01. Hmm. For more importantly, we go here. We don't change this, then we mess up everything. So we want to be a laminar flow. Did it change anything here? Perfect. Go to fluid, go to our air. There you go. So for the case of my projects here, we're going to make this constant at 1. For this case, in a future case, we do change it to 0.5 to make our Raymond's number what we need it to be. That's going to be for our hybrid flow. We change it to 0.5. I'll show that later on in the video. But in our case, we change this to 1, and then viscosity is going to be 1 e to negative 0.5. And make sure this says air, change and create, and then close. Perfect. Oh, it doesn't matter. Our boundary conditions, let's check this out. It's going to be double click our velocity inlet. So since we're doing Poisson flow, we're going to make our velocity, in our case, 0.13, whoa, 1333. Make sure this is, oh, do what I needed. Let's edit our outlet, prevent. We want to make sure we prevent reverse flow. The lower wall, make sure this is stationary and no slip for Poisson. Here, make sure the same thing. Stationary and no slip. For this case, with the things we've chosen, we're going to get a Reynolds number of 2000, which is perfect for laminar. Just at the edge for laminar flow. Where we select all of that, I'll go to my reference values, make sure everything's updated. We want to do it from the inlet to our surface body. Make sure this is all the same thing I chose. Our density is 1, velocity is what we chose, 0.11333, and our viscosity is that. Then we go to solution. We initialize. We're initializing right here. Then we run calculation. From here, we're going to do 150 iterations. If all of this is fine. Conservative, automatic. Yeah, should all be good. So now we're calculating. And then it's calculating. Mm-hmm. Calculating. Calculating. For our workbench, our results. I'm gonna open our results. If anything, I'll just go back to the one I previously did to show the correct results, but I don't know where I messed up. Hopefully the audio isn't corrupted. Once it opens, I'll get back. All right, now that we got it to do or open, we open our Z-axis right there. Gonna have to set up a few things. We could close these as well if we want, because they're fine, but don't worry. We're gonna first add our lines. We're gonna have a midpoint line. Since we chose 1500 as our thing, the midpoint would be 0.75. This is in meters. And we have to put a zero point 0.1 for it to work. If we apply, should be a line right there. Perfect. Gonna do another line right there. It's gonna be our end line. We're gonna do it right before our, and if not, our velocity won't be displayed. And we're also gonna do, oh, why did my end line go there? Edit my samples. Now, why did my end line go here and not there? Well, I'm gonna open what I previously had done and show the changes. Not too sure why it's not working right. I'll close these. We'll open our original point cell flow one because I don't understand why the end line is showing up at the beginning. Here you can see our contour that's meant to be at the end, but it's all right. Our end line. Oh, I was meant to do 1.5. Whoops. That is why it's not working. Oh, we'll go back. I'll jump back in. So here we are to do 1.5. Well, 499. No, try that. Then we do it. Doesn't really matter where you place this, as long as it's not at the very beginning and any other sample. And oh, that should be. So here we see our three lines. Now we're gonna generate a contour. Symmetry one. This is gonna be velocity U. Gonna change this to 110. And then I'll apply right there. Should load. I'll get back when it fully, oh, there you go, fully loads. We can double click right here, horizontal, and then the thick, and make it nicer for us. We go down here into our chart. Where's our chart? Insert a chart right here. This title, boy, velocity, profile, or boy, cell. It's kind of a difficult spelling. Apply that. Just keep it. Data series, series one, series two, series three. We're gonna call this midline. And the location is gonna be our midline. This is gonna be end line. And the location is gonna be end line. And this is gonna be developing region. And this is gonna be the developing region. And if we apply that all, oh, fully constant. Oh, wait, I forgot to change over here. The axis we're gonna use, it's gonna be, our y-axis is y. Now, oh, we did our developing region too early. If we delete our developing region though, and then apply that, yeah, everything should be bounded on top of each other. If I move back my developing region, will it be better? Oh, shit. Yeah, if I make it bef I made it too soon. I go to my chart, data series, new one, developing. Our developing regions right here. So you can see our velocity is developing at the midline, it's already fully developed, and at the end line, it's the same. So yeah, our flow is fully developed by the time it reaches midline and definitely by the end line. But by our midline, you can see that it's not fully developed yet. We haven't reached our full velocity yet, which we chose wasn't near this number. So it does semi-correlate. But now I'm going to be showing my other setups for my covette flow and my hybrid flow. The main differences between these are not going to be anything with the geometry or the meshing, so I'm just going to go straight into our setup right here and show you guys the key differences. As I said before, oh, double precision, same thing we did previously. Make sure I'm recording. All right. So now we're opening our covette flow. Close the voice flow because it's going to slow my computer. There you go. Opening my setup. And it's still loading. So, as you can see, same mesh that we had previously, but we're gonna go to our model, make sure it's laminar like we did have it before. I'm gonna go to fluid. Our density And our opening density stays the same, but I did change my viscosity to 0.001. That's just so my Reynolds number could be uh 150, which would fall in the laminar category. Make sure everything's okay. Solid is still the same. Now we go to our boundary conditions. This is where some things change. So I'm gonna actually right click here and edit. No, right click there, type. It used to be velocity inlet. Now it's going to be pressure inlet since it's going to be co-wet flow. But we'll go into here. Here, I want to make sure that I prevent reverse flow. And then I go here, and same thing, I want to prevent reverse flow. And go. For our lower wall, I want a stationary wall. So I'm going to check stationary, no slip. But for our upper wall, we're going to have a little difference right there. We're actually going to want a moving wall. No slip is the same. We want a moving wall, and we chose a velocity of 15 meters per second to make our Reynolds number work. We go down here to our reference values, make sure everything's okay, and refresh this just in case. But you can see that's exactly what we chose. Then I'll go to solution, initialize it, and then run calculation. Same thing, 150. Calculating. Shouldn't take too long. I'll get back when it's fully done. Right, now that we're recording again, yeah. I'm gonna go back to my workbench, double click results. I have the same contour setup, midline setup, and endline setup, and developing region setup as I did in the previous one. So it should all look very nice. If it loads. Go, my contour's loading. Perfect. See, my contour looks more a little different than it did previously. But if we go to our velocity profile, see what I did over here. Just made a data line for midline and endline. Developing region wouldn't make sense since this is just linear flow, bar covet flow. But we did get a linear line right here, and it does approach our velocity that we did choose. My x-axis is u, y-axis is y. End line, midline, same thing I did previously, but this time we just ended up with a linear flow. Now, if I go, let me close this for my co-wet flow, and let me close these. My computer doesn't cry. We're gonna go to our hybrid flow. Now the setup for this is gonna look a little bit more different than it did for the other two, because now we combine our Poisson and our Covet flow, Poisson flow. Now we're gonna have a moving plate and a velocity. Loads. Yes, again, same dimensions as I did in the first one. All I'm changing is our viscosities are actually in this case I do change my density to 0.5 to make it work. Let me see. But dimensions yet again are 10 millimeter height and 1,500 millimeter length. No, perfect. So yet again, I'll check my fluid, my air, actually first, laminar. I'm gonna go to air this time, and I'm gonna have to change I did make my viscosity a bit larger than I did before. Actually, in my work, that So I actually didn't change my viscosity, but I did change my density to make it work. It's all the same. That's all the same. Here's where things are going to change. So if from the previous one you copied that one or did something, this is going to become velocity inlet. Same thing we change over here, type, and we go to inlet velocity. We're going to go here, edit that. Here we're going to be choosing this as our velocity 0.8, and that's what I chose to make my Reynolds number 5.5, way below anything turbulent, just in case. But yeah, 0.8. We're going to go over here. There's going to be a pressure. Remember to revert pressure, prevent reverse flow. And apply, close. Our lower wall, once it opens, stationary, no slip. But our upper wall is going to have a velocity as well. Gonna have a moving plate, and we chose 0.6 as our speed to make our Reynolds number correct. Now I go to my reference values, make sure everything's exactly what I chose. I'm gonna refresh by clicking that, and here you can see, refreshed. Where's my viscosity? Perfect. So now I'm gonna go solutions, initialize. Let's see it initializing. I'm gonna go through the same steps. So I'll pause and get back to you guys when it's ready. Now we're resuming. Everything finished our calculations. So we head right back to our workbench right here. Double click results. Same contour, same end lines and midline, and we don't need a developing region for this one, I believe. Did everything load perfectly and my own computer. You got it. Perfect. Everything worked. We can see our contour is a little different in this one, which is good news. Go to our velocity profile, and here's what we got. For this one, data series, we do have a developing flow on this one. It's all lined up on each other. Could move it back to see if anything changes. Developing flow, if I make it a little further back. Maybe we have some differences. Yep, there you go. So we have our developing region right there, and our end line and develop and midline are overlapping each other. And we don't end up with a linear flow because we have a hybrid flow right here. Go back to this, same thing, X is U, Y, we have our three things. But yeah, that's our three cases right there. I hope you enjoyed the video and gladly see you next time. Have a great rest of your day, whoever watched this.